So welcome to Sotantra education. In this lecture we are going to discuss some more concepts on array. So previously we have discussed that array is a collection of variables of the same type, or we can say array is a collection of elements of the same type. So we can write like this: collection of elements or variables of same type. So this one is important, that is same type. Okay, so you can make an array of ints, you can make an array of doubles or any other type, but all the values in an array must have the same type. For example, consider one array AR and the elements of this array are 5, 7 to 153. So assume these are the 4 elements in an array AR, and AR is the name of the array or the reference variable. So here you can consider this 5 is int, 7 is also int, 2 is also int, 153 also int, and this is an array of ints, or you can say array of integer variable. Similarly, you can consider another array, that is, assume the name of the array is AR1. So here the elements are 2.3, 7.319, another is assume 15.25, another assume 17.53, like this. So here we can say this is an array of doubles, or double values, because this 2.3 is of type double, this one is also type of double, this one is of type double, this one is of type double. So all the elements in an array are of same type, and you can create an array of integers, array of doubles, array of characters, array of any other type, but all the elements of one array should be of same type. So similarly, we can consider arrays as elements of an array. So for example, we can consider this one, assume one array and the name of the array is AR2, and here the elements are arrays. So 10, 20, 30 is one array. Similarly, 40, 50, 60 is another array. Similarly, we can consider 70, 80, 90 is another array, and this one 10, 20, 30 is one array, this one is also one array, this one is also one array. Now here you can observe AR2 is an array whose elements are arrays. So for simplicity, take the name as AR. So instead of AR2, assume the name is AR. Now we can write this, or in AR this 10, 20, 30, we can write this as AR of 0. So this one is AR of 0. Now this one 40, 50, 60. So this is the second, this array we can write this as AR of 1. and this one we can write AR of 2, 70, 80, 90. So thus in this way we can write AR of 0 is one array and the elements of this array are 10, 20, 30. Then how to assess the element, suppose for example 10 in AR of 0. So AR of 0 is an array that is 10, 20, 30. So how to assess this element 10 here? So to assess this element 10 we can write like this: AR of 0 then 0, because this one is at index 0 in AR of 0. So to assess 10 we can write AR of 0, 0. Similarly we can write AR of 0, 1 to assess this 20. Similarly we can write AR of 0, 2 to assess this 30. Okay, so now consider the complete array once again here. So I am writing that one once again. So AR is the array and the elements are 10, 20, 30, then 40, 50, 60, then 70, 80, 90, and this is the array. Now to assess this 10 we can write, so let it be a different color. We can write AR of 0, 0 to assess 10. Similarly to assess 20 we can write AR of 0, 1, so this one. Similarly to assess 30 we can write AR of 0, 2, this one. Now to assess 40 we can write AR of 1, 1 to assess 40, this one. Sorry, 1, 0, it is 1, 0. Now to assess 50 we can write AR of 1, 1. Similarly to assess 60 we can write AR of 1, 2. Now how to assess 70? So to assess 70 we can write AR of 2, 0 to assess 70. Similarly how to assess 80? So AR of 2, 1, so to assess 80. Then how to assess 90? So AR of 2, 2 to assess 90 here. So it is simple. So here you can observe two indices required to identify one element. So in this array you can consider any element, suppose is it 10, so two indices required, 0, 0. Similarly consider another one, suppose it is 50. So to assess this one we need two indices, that is AR of 1, 1. Similarly consider this one. So to assess 90 we also need two indices, AR of 2, 2, where AR is the name of the array and these 2, 2 are two indices. Now the array that requires two indices to identify each element is called two-dimensional array. So here we can write the array that requires two indices to identify each element is called two-dimensional array. or we can write this one as 2D array, 2-dimensional. In short, we can write 2D. So in 2-dimensional arrays, the elements are 1-dimensional array. So here you can consider, so the 2-dimensional array name is AR, and here the elements in AR are 1-dimensional array. So 10, 20, 30 is 1-dimensional array, 40, 50, 60 is another 1-dimensional array, 70, 80, 90 is another 1-dimensional array, like this. So now we will discuss how to declare variables of 2-dimensional arrays and create 2-dimensional array. So we have previously discussed that to declare an 1-dimensional array variable, we were writing like this: int, then this one AR, like this, or right here array name. So in this way we are declaring an 1-dimensional array. Now to declare 2-dimensional array, we need to use 2 square bracket. So this one array name. So this one is for 1-dimensional array. The first one is for 1-dimensional array. The second one is for 2-dimensional array. So the difference is this one. You need to give 2 square brackets for 2-dimensional array and 1 square bracket for 1-dimensional array. Suppose consider one example like int, this one AR. Similarly, we can consider another one like double, this one, assume the name is matrix, like this. So here this statement double, then this 2 square bracket, then matrix. So this statement declares 2D array variable matrix of double value. This statement declares 2D array variable AR of int values, like this. So we can say the syntax for declaring a 2-dimensional array is the element type, then 2 square brackets, then array reference variable, or we can say this one is array name. So type of the element, then 2 square bracket, then array reference variable name or array name, simply we can say. So here you can observe 2 subscripts or 2 indices required in a 2-dimensional array, or we can say 2 subscripts or 2 indices are used in a 2-dimensional array. So one for row and another one for column you can consider. So we can write that this one, suppose, let me write once again here, suppose int AR. So here you can consider this one as row and the second one is for column. Hence 2-dimensional arrays are often used to represent tables or matrix of data arranged in rows and column, because we can represent one index with row and another index with column. So hence 2-dimensional arrays are used to represent tables or matrix of data arranged in rows and columns. Now we will see how to create a 2-dimensional array. Suppose we want to create a 2-dimensional array of size 5 by 5. int values and assign it to AR. So for example, we can write this one AR equal to new int this 5 and 5. So it creates a two-dimensional array of 5 rows and 5 columns and assigns the reference to AR. Or we can combine these statements, these two statements, and we can also write in a single line like this. So int AR equal to new int 5. Okay, we have discussed that double matrix. So this statement declares 2D variable matrix of double values. Now we can create a two-dimensional array of 3 by 3 double values and assign it to matrix using the statement matrix equal to new double 3 3. Or in a single line we can combine these two statements and write in a single line like this. So double matrix equal to new double 3 3. So these two statements or two lines are equivalent to this single line. So these two statements or two lines are equivalent to this single line. So now consider another example, that is we can write int values that is equal to new int 3 3. So it is going to create a two-dimensional array of size 3 by 3, or we can say a table that has 3 rows and 3 columns. So consider a figure like this. So this one is row 0, this one is row 1, this one is row 2. Similarly, this one is column 0, this one is column 1, this one is column 2. So we can write like this. This is 0 1 2, this is 0 1 2. Now if we want to assign, for example, a value 7 to a specific element, that is row 2 and column 1. So row 2 and column 1, so row 2 means this row and column 1, so this one. So if we want to assign a specific value to an element row 2 7 1, that means this one. So here if we want to assign a specific value, suppose consider this specific value is 7. Now we can write values, because the name of the array is values, then row 2 column 1 equal to 7. So you can write like this. and when we create the array, by default the values are 0 for integer array. Okay, now in this way values 2 1 equal to 7, in this way we can assign the elements to some specific values, or we can initialize the array in this way. So here you can observe this one is the name of the array, and this one is the row, this one is the column, and this one is the value, specific value which we want to assign. So in this way you can initialize the two-dimensional array. So following this procedure we can initialize a two-dimensional array. We can also use an array initializer to declare, create and initialize a two-dimensional array. We have studied in the previous lecture how to create, initialize, or how to declare, create and initialize a one-dimensional array using array initializer. Now we will discuss how to use array initializer to declare, create and initialize a two-dimensional array. Suppose consider the array name is AR, so you can write like this: int AR equal to 1 2 3 then 4 5 6. So this statement is equivalent to int AR equal to new int, then here how many rows are there? 2 rows are there, so you can write new int 2, and here how many columns are there in each row? 3 columns are there, so you can write 3. And we need to initialize also. So the element at 0th row and 0th column is initialized with 1. Similarly, the element at 0th row and 1 column is initialized with 2. Similarly, the element that is at 0th row and 2 column or second column is initialized with 3. So like this we can write AR of 0 0 is 1, then AR of 0 1 is 2, then AR of 0 2 is 3, then AR of 0 it is 1, so 1 0 is 4, AR of 1 1 is 5, AR of 1 2 is 6. So this statement int AR equal to 1 2 3 4 5, so this statement is equivalent to these statements, or we can write like this. So these statements. So this single line is equivalent to all the statements written inside the red box. Okay, so now consider the array AR and the elements are like this 4 5 6. So we have discussed that a two-dimensional array is actually an array in which each element is a one dimensional array. Now consider AR is a two dimensional array and the elements of AR is 1, 2, 3 and 4, 5, 6 and these 1, 2, 3 and 4, 5, 6 are also one dimensional array. So this one I can write as AR of 0 that we have already discussed, and this one we can write as AR of 1. Okay. Now the length and size, the length or size of an array is the number of elements in the array. We know this. The length or size of an array is the number of elements in the array, and we know that the length of an array can be obtained using the expression that is array name dot length. So this one gives the length of the array. Now in this example, if we want to find the length of the array AR, so we can write this one AR dot length. AR dot length. So AR dot length gives the length as 2, because in the number of elements in AR is 2. This is 1 and this is 1. So one element is 1, 2, 3, another element is 4, 5, 6. So AR dot length is going to give 2. Now consider another example. Suppose we have another array that is BR and the elements are like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So another array is BR, and we can write this one as BR of 0. We can write this one as BR of 1, this one BR of 2, and this one BR of 3. So here if we write BR dot length, so it is going to give 4, because BR has 4 elements. One is this one, next one is this, next is this, next is this. So BR dot length is going to give 4, because there are 4 elements in the array BR. So here you can observe this BR of 0 is also another array, BR of 1 is also one array, BR of 2 is also one array, and BR of 3 is also one array. So here BR of 0, BR of 1, BR of 2, BR of 3 are also arrays. So their length we can also found using BR 0 dot length, BR 1 dot length, like this. So here if we write BR of 0 dot length, so it is going to give 3, because BR of 0 contains 3 elements, that these are 1, 2 and 3. So it is going to give 3. Similarly, if we write BR of 1 dot length, it is also going to give 3, because in BR of 1 3 elements are there, one is 4, another one is 5, another one is 6. Similarly, BR of 2 dot length is going to give 3, BR of 3 dot length is also going to give 3. Now consider another example, that is if we write x equal to new int 3, 4. So here x of 0, x of 1, then x of 2 are one dimensional arrays, and each array contains 4 elements. So if we write like x dot length, so it is going to give 3, and if we write x of 0 dot length, it is going to give 4. If we write x of 1 dot length, it is also going to give 4. If we write x of 2 dot length, it is also going to give 4. Or we can say this x dot length is 3 here, so this one is equivalent to number of rows in x, and this one x of 0 dot length we can write number of columns in row 0, and x of 1 dot length is 4, and we can write this one as number of columns in row 1, and this one x of 2 dot length we can write number of columns in row 2, like this. So you can consider this one, the figure here. So here x refers to this one, and the elements are x0, x1 and x2. It has 3 elements, and x0 refers to another array, that is x of 0 0, x of 0 1, x of 0 2, x of 0 3 are the elements. Similarly, x of 1 refers to another one dimensional array, and x of 2 refers another one dimensional array, and the elements are x of 2 0, 2 1, 2 2, 2 3, like this. And x dot length is 3 because it has 3 elements, one is x0, x1, x2. Similarly, x0 dot length is 4 because x of 0 has 4 elements. This one x of 0 refers to this one, and this one has 4 elements. Similarly, x of 1 dot length is 4 because it has 4 elements. Similarly, x of 2 has length 4 because it has 4 elements. So you can consider the figure that represents the pictorial representation of a 2-dimensional array. So here you can observe each row in a 2-dimensional array is also an array, and in this example the number of columns in row 0 is 4. Similarly, the number of columns in row 1 is 4. Number of columns in row 2 is 4. So here all the rows have 4 number of columns, but in some situations the rows can have also different length. That means the row 0 may contain 5 columns, the row 1 may contain 6 columns, the row 2 may contain 2 columns. So like that. So we can represent this, like we can represent different lengths of each row in a 2D array like this. In this one, suppose the array name is BR and the elements are 1 2 and 3 4 5. So here you can observe BR dot length is equal to 2 here. So BR dot length gives 2 here because BR has 2 elements or 2 arrays. One is this one and another one is this one, or we can say in this representation 2 rows are there. Now what will be the value of br0 dot length? So it is going to give 2 because it is br0 has 2 elements and these are 1 and 2. Similarly, we can write br of 1 dot length. So it is going to give 3 because br1 has 3 elements and these are 3, 4 and 5. So here this one int br equal to 1, 2, 3, 4, 5. So we have represented this array br using array initializer. Now we can also create a two-dimensional array in which each row has different number of columns using the array creation expression. So how to use array creation expression to create a two-dimensional array where each row has different number of columns. So consider this one like int, assume the name of the array is cr. So you can write here new int 2 and make this one empty. So here in place of row we are writing 2. That means the array has 2 rows and number of columns is not defined till now. So now we will write the number of columns in cr0. So for that we can write cr0 equal to new int 5, or we can say the row cr0 or row 0 has 5 columns. Similarly, we can write cr of 1 equal to new int suppose 3. Now row 1 has 3 columns. So this statement says that row 1 has 3 columns and this statement says that row 0 has 5 columns, and this one says that cr is an array in which it has 2 rows and the number of columns is not defined here, or this statement creates only 2 rows. Now we will solve some basic programs using the concepts of two-dimensional array. Now suppose we want to write a program for creating one array and initialize that array and print the array. Two-dimensional array here. So create a two-dimensional array, initialize the two-dimensional array and print the array. So to create a two-dimensional array we can write this one. First we need to write int square bracket, then ar equal to new int, then the row number and column number. Suppose 2 is the row number, 3 is the column number. So we can write new int 2, 3. Then we need to initialize the array. So for this we can write ar of 0, 0 equal to, suppose if we want to randomly initialize we can write like this math dot random. So this math dot random is going to produce a random value, random double value between 0 to 1. So we can multiply 100 to that value and convert this double into int value. So in this way you can write ar of 0, 0 equal to int math dot random into 100. Similarly, we can write AR of 0 1 is equal to int math dot random into 100. Similarly, we can initialize one by one. So instead of doing this, that means initializing one by one, we can also write a loop, and using the loop we can initialize. So for row 02 AR dot length, then for column 02 AR of this row dot length, then AR of row column equal to this one int math dot random into 100. We can write in this way. So we can use a, instead of repeatedly writing 0 0 0 1 0 2 like this, we can use a loop, and the loop starts from row 02 AR dot length, and when the row is 0, the column 02 AR of 0 dot length, that means AR of 0 dot length. So number of columns in 0th row. Similarly, number of columns in first row, number of columns in second row, like this. AR of row column equal to int math random into 100. Now for printing the elements of the array, we can use another for loop. So for row 02 AR dot length, so AR dot length keeps the maximum number of row or total number of row. So AR dot length gives the total number of rows. Similarly, for columns we can write another loop. So for column 02 AR of row dot length, and print system dot out dot print AR of row and column. So it is going to print the value at AR of row and column. So first create the array like this, then initialize the array. So this is initialization manually one element at a time, so it is not preferable. So instead of this, we can initialize using a loop, and similarly following this loop we can also print the elements of the array or display the elements of the array, two-dimensional array here consider. So this is the simple program, or this is the complete program that creates, initializes and prints the array. So class test public static void main int AR equal to new int 2 3. So here 2 is the number of rows and 3 is the number of column, and AR is the name of the two-dimensional array. So for int I equal to 0, I less than AR dot length. So AR dot length gives the number of rows in AR. So in this example it is 2. Then I plus plus. Then for int j equal to 0, j less than AR of I dot length. So AR of I dot length gives the number of columns at row I. Then j plus plus. Then AR of ij equal to int math dot random into 100. So it is randomly initialized AR of ij. So here we are writing I and j for row and column. So simple. Now this one, this for loop is for printing the element. So for I equal to 0, I less than AR dot length I plus plus. Similarly for j equal to 0, j less than AR dot I ar of I dot length j plus plus, print ar of ij, then some space. Then after printing this one, or after printing one column, sorry, after printing one row, then print a new line, and after the new line print another row like this. So one row, then next line another row, then next line another row like this. So this is the complete program that creates the array. So this statement is for creating the array, and this one is for initializing the array, and this one is for displaying the array. So now consider another program, that is to find the sum of the elements of a two-dimensional array. So we can create the array like this. Previously we have discussed. So int ar equal to new int assume 2 3. So here 2 number of rows and 3 number of columns, or any value you can give here. In place of 2 3 you can give any value. Now suppose we want to initialize randomly, or we can take the input from the user. So we can write like this: for I equal to 0, I less than ar dot length I plus plus, then for j equal to 0, j less than ar of I dot length, that means the number of columns in row I. Then j plus plus. So here the outer for loop, this one is for number of rows, or we can say this one runs for number of rows, or this represents number of rows, and the inner loop represents the number of columns, or this inner loop is for number of columns, or this one deals with number of columns. That's why we are writing j less than ar of I dot length. So ar of I dot length number of columns are there in row I. Okay, now we can write this one: ar of I j equal to, you can use math dot random to initialize, or we can take the input from the user, ip dot next int, where ip is a scanner class object. So in this way you can take the input from the user and initialize. Now how to find the sum? So to find the sum, we can take one variable and initially sum is 0. Now we can write the same loop: for I equal to 0, I less than ar dot length I plus plus, then again for j equal to 0, or consider column equal to 0, then j less than ar of I dot length j plus plus, then we can write here sum equal to sum plus ar of I j. Then at the end we can print, after the loop, print sum, or we can print the value of sum is like this. So this is the simple concept to find the sum of all the elements in the two-dimensional array or in a two-dimensional array. So you can see the complete program here. java.util.scanner to take the input from the user. So here we are initializing the array by taking inputs from the user, and this statement creates the array. So new int 2 2, here the array size is of 2 2, so that means the row is 2 and column is 2. Then enter the array elements. So we are creating a loop I equal to 0, I less than ar dot length, for j equal to 0, j less than ar of I dot length, ar of I j equal to ip dot next int. So this one is for taking inputs from the user and initializing the two-dimensional array like we have discussed. Now this one is for printing the array. So this part is already discussed in the previous program. So for I equal to 0, I less than ar dot length, for j equal to 0, j less than ar of I dot length, print ar of ij. So this part already we have discussed. Now we want to find the sum of all the elements. So initially we are writing sum equal to 0, then using the loop we are just updating sum equal to sum plus ar of ij, and at the end we are printing the sum. Now consider another simple program, that is to find the sum of the elements row wise. So in a two-dimensional array or in a table, find row wise sum. Suppose consider the elements of the array as like this: 1 2 3 and 4 5 6, then 7 8 9. So if we want to find the row wise sum, so it is going to 6, it is going to 15, it is going to 24. So how we compute the sum or how we get the result? So in the first row we can write sum equal to 0. So we can take a variable sum equal to 0, then add this one sum equal to sum plus, assume the array name is ar. So ar of 0 0, that means sum becomes 0 plus 1, that is equal to 1. Then again add 2, that means we can write sum equal to sum plus ar of 0 1. So the value of ar of 0 1 is 2, so we can write 1 plus 2, that is equal to 3. So this one is the previous sum. Now again we can write like this: sum equal to sum plus air of 0 2, then this one is 3 plus 3, so it is equal to 6. So after completing one row we can write the sum in row 0 is 6. Then again initialize the sum to 0, sum equal to 0, then write the same formula: sum equal to sum plus air of 1 0, then sum equal to sum plus air of 1 1, then sum equal to sum plus air of 1 2. So like this. So instead of repeatedly writing this air of 1 0 1 1 1 2, we can use a loop. Similarly here, instead of writing air 0 0 air 0 1 air of 0 2, or sum equal to sum plus air of 0 0 sum equal to sum plus air 0 1 sum equal to sum plus air 0 2, we can use a loop. And after completing the sum in one row, we can print the value of sum and again initialize the sum to 0. So you can see the program like this. So this part is for initializing the array. So it is for initializing the array, and this one int ar equal to new int 4 4, it is for array creation and declaration. First we create the array, then initialize the array with random elements, and this one we have also already discussed. This one is for printing the array or displaying the array. So here we are considering two-dimensional array. So displaying the two-dimensional array, we have already discussed this program, this part in previous program. Now here we are going to compute the sum in row wise. So for that we are taking row equal to 0, row less than air dot length row plus plus. We are using a loop that is going to consider the row. Then we are considering the variable sum, and initially it is 0. Then for column equal to 0, column less than air of row dot length column plus plus, sum equal to sum plus air of row and column. Then when this inner loop terminates, print the sum value, then again initialize the sum value to 0, and again this loop is going to execute and counts the sum or computes the sum. This loop is going to execute and computes the sum in one row. Then when the loop terminates, print the sum and again initialize the sum and again compute the sum in one row and print. So this one is the simple one to print and compute row wise sum. So now we will discuss how to pass an array to methods. So when passing an array to a method, the reference of the array is passed to the method. So just pass the reference of the array, or you can simply say the name of the array. Suppose consider we have one array and the name of the array is AR and the elements are 1, 2, 3, 4, 5 like this. So here AR is the name of the array, or you can say AR is the reference to the array. And suppose we want to pass this array AR to a method print array. So we have a method print array and we want to pass this array AR to this method. So just pass AR like this. So without any square bracket, just pass the name of the array. And every array object knows its length. So here in this example also AR knows its length, and we can find the length of AR like this, AR dot length, or we can find the size of AR like AR dot length. So it is not required to pass the array length as an additional argument. Only name of the array or reference of the array is sufficient. Do not pass the length of the array as an additional argument, because every array knows its length. Okay, so now we will discuss how one method is going to receive an array reference through a method call. So the method's parameter list must specify an array parameter to receive an array reference. For example, if we want to write the header of print array, so the print array like this, void print array. So this method can receive one array reference as a parameter. So for this we can write here int, so let the name is my AR. So this is the header of the method print array. So here we can see the method's parameter list is specifying one array parameter. The print array method here receives the reference of a int array in parameter list. So now you can write the body of the method, a simple one for print array like this. We can write, so let it be complete one, public static void we can write here. So before this we can write public static void print array int my AR. Then we can write for I equal to 0, I less than my AR dot length, then I plus plus system dot out dot println my AR of I. So it is a simple one. Okay, so previously we have discussed that when a method is called, a copy of the argument's value is passed to the called method. So like while we are discussing the concept of methods, at that time we have discussed, suppose one method is there, assume my method. So when we pass an argument, suppose my method, pass a, my method is like this, the header of the my method is assume like this, public static void my method, then int b, like this. So here you can observe, when we call a method, the copy of the argument, that is this a, is passed to here the b. The copy of a is passed to b, we have already discussed. Or we can say the copy of the argument's value is passed to the called method. So when the argument is a primitive type, so what are the primitive types? So when the argument is a primitive type, so what are the primitive types? So we have 8 primitive types like this: int, char, byte, short, long, double, float, boolean. So these 8 types in Java are called as primitive types. So these are primitive types. So except these 8, all others are reference types or non-primitive type. So when the argument is a primitive type, so here you can consider, here a is the argument. So what is the type of a? So here it is int, because we can see here my method is receiving one integer. So the type of a is int. So int is a primitive type. We have written here int is a primitive type. So when the argument is a primitive type, the called method, this one, the called method, receives a copy of the primitive type, or we can say in this example b is a copy of a, and the called method works exclusively with the copy. So the called method here, this one, works with b, so which is a copy of a. So if the method my method here makes some change to the variable b, then that is not going to affect a. We have discussed in the previous lectures while we are discussing methods. So if the method, inside this method we write suppose b equal or b equal to b into 10, like this. So here the b value is multiplied with 10, but that thing is not going to affect a. So changes to the called method's copy do not affect the original variable's value in the caller. So any change to b is not going to affect a. Or we can say when a method modifies a primitive type parameter, changes to the parameter have no effect on the original argument value in the calling method. Now consider the other one, that is when this one, this a is a reference type, that means non-primitive type. So for non-primitive type, consider this one is one array, or we can write this like int array b. So we know that array is a reference type, it is not a primitive type. So here you can find in the list array is not there. Now when the argument is a reference type, so here a is a reference type or name of the array, or here you can see this one print array ar. So here ar is a array variable name, so here ar is an array. So when this argument is a reference type, that means not a primitive type, the called method receives a copy of the reference that was passed as an argument. So here b is a copy of the reference to a, or b receives a copy of a. So when we call this method my method a, then B is going to receive a copy of A. So what is A? So A is a reference, and what is B? So B is the copy of that reference. So what is reference? Like you can see here, suppose we have one array and the elements are 1 2 3 4. So here we are calling that name of the array is AR, or AR is a reference variable. That means AR refers to this array 1 2 3 4, or AR points to this array, or we can say AR stores the address of this array. Now when we pass this AR to a method and my array receives the copy of AR, that means assume my AR receives the copy of this AR, then we can say my AR is also stores or gets the address of this array, or my AR also refers to this array. Now if we make any change in the called method through my AR, then that is going to affect the original array that is referred by AR, or we can say AR and my AR both refers to the same array. So if we make any change in the called method, then that is going to reflected in the caller method. So here, with a reference to an object, the called method can manipulate the caller's object directly. So consider one example here. So consider this example. Here we have a class test, public static void main, then int AR equal to 10 11 12 13. Suppose we have one integer array AR and the elements are 10 11 12 13, and modify element AR of 0. Now we are calling a method modify element and passing AR of 0 as the argument. So what is AR of 0? It is 10. Now when we call this method, the control comes to the modify element. So here this one. So modify element receives the copy of AR of 0 in n, and it updates n into n is equal to n into 10. So the value of n becomes 100. So n becomes 100 here. But here you can observe when we execute this method, so it is going to display 10 here, because here we are updating the copy of a primitive type, or because you can see here AR of 0 is a primitive type, and if we make any change in the copy of the primitive type, then that is not going to affect the original one. Now consider this one, the second method, that is modify AR, modify array AR. So here AR is a reference type. So when AR is passed as an argument, so here my array receives the same reference. So here AR and my array refers to the same array, that is 10 11 12 13. So here the array is like this 10 11 12 13, and AR refers to this one. So when modify array AR is called, then this modify array method receives the reference at my array. So my array refers to this same array. Now if we update my array of 0 equal to my array of 0 into 10, so this one 10 becomes 100, this becomes 100, and it is as both AR and my array refers to the same array, this change is permanent, or this change in the caller method, this change in the called method can be reflected in the caller method. So after this method, when we execute this statement after calling modify array method, that is printing all the elements. So here we are going to get the elements are 100, 11, 12 and 30. Similarly, you can pass a two-dimensional array to a method by simply passing the reference as an argument. So similarly, when a method returns an array, the reference of the array is returned. So for example, consider a simple example. Consider a simple program. Public static int AR. So this method is going to return one integer array, and assume the name of the method is reverse, and it is taking one integer array in the parameter, and assume the name is list. So here we can reverse the array element. So we are writing the program to reverse the elements equal to 0. So for int I equal to 0, then comma j equal to list dot length -1. Your list is the name of the array. Then the condition is I less than j, then I plus plus j minus minus. So we have already discussed the program how to reverse the elements of an array. So that program only we are writing. Now write int temp equal to list of I, then write list of I equal to list of j, then you can write list of j equal to temp. So in this way we are going to reverse the elements of the array. So this give curly braces here. Now when we want to return this array list, so simply write return the name of the array or name of the reference variable. So simply write return list. So to return an array from a method, just return the reference of the array. So similar to this one.